Great. Yes, so I see many of you have also submitted the solution to the assignment. Did you enjoy it?
Yes.
Was easy, too easy.
Not, yeah, it is basically easy, but not that much easy as we expected. But yeah, there is,
That, yes.
yeah, we enjoyed it.
Yes, yes. How you tried out? Where you tried the solution? Were you able to verify it?
Yes, I have run the website you have shown na on Saturday.
Okay, from
that, yes, PG, right.
pg-sql.com. Okay.
So I have run the queries. So yeah, most of the things I got, but last thing like you told na, we need to calculate the total by the month, right?
Yes.
So
Yes.
I can able to calculate the total, but month wise I'm not able to do.
Okay. Okay. I shared a link to the SQL tutorial also. So if you go through it, then it would be easy.
Then one more thing regarding the index, there was one question to create an index, right? So how do we find the how the execution time, and how do we identify the performance after the index creation? So how do we check that?
Yes, we'll be covering that today. Yeah. So there is a command, explain command. So with that you can do, if you are on a real Postgres, as an admin, you can use a tool called PG admin, right? So that can also give you insights about the performance. There are various techniques, we'll cover them. Yes. But yes, I'll cover them from high level, which is suitable for system design interviews. In depth, you can try and you can figure it out. You should install also Postgres or MySQL, any database. And then with different databases, there will be different admin tools. From the admin tools, you will be able to get performance related information about each of the running queries. We'll be covering that. We talk about pagination today. So we'll start with various other topics. There are so many topics and we can do it, but yes. We'll cover them and we'll cover some interesting scenarios where you have some data and you have to find some interesting informations. And also I'll share you about pagination. Pagination is an important concept. And yes, anyone knows about pagination? What does I mean with that?
Yeah.
Displaying a set of a limit number of records.
We cannot load millions of rows into the memory. So we split into chunks and we will load into the memory.
Sure, sure. Yes, absolutely. Right. So, yes, let me talk about pagination. I have shared my screen. Hope you are able to view my screen. Correct? Is it visible?
It's visible, Tarun.
Pardon?
It's visible, Tarun. I can see it.
Good, good. Yes. Yeah. Technically, it's sharing, but yes, better to verify, test it. Yes. So need real input. So that's the reason. Yes. Pagination, as you all know, when we go to Google, right? So you search for any item. Say, for example, let's search for some item like Postgres, right? Postgres, let's say Postgres SQL. When I see that, okay, there will be many results. Yes. So you have these pages 1, 2, 3, 4. What they have done is they have shown you few results. So in the page, maybe they are showing top 10 results. But yes, I can scroll to the next page. Then I see more results. So here, this is kind of a list of links which are having information related to the keyword PostgreSQL. But yes, it is showing one by one. It's not showing all the links at the same time. Can anyone tell what is the reason for this? What is the advantage of pagination?
Yeah, so advantage is basically like, let's suppose as you search Postgres, right? So in that case, it might be 1,000 results for the same. But since we have pagination concept, that's why it is displaying that top 10. Let's suppose in first page, it is displaying 10 result and the next page 10 results, something like that. So performance will be better in that case. That
Correct.
means, yeah.
Absolutely. So this is for the performance reason. People view applications over the right. So perfect. So yes, the advantage is you save performance because users may be using a mobile app. They may not have that screen. So what is visible to you is maybe one page of information, right? But yes, if there is long list of data, there's not no need to share all of the data to the users. In case required, they can move to the pages. So this is one concept. There is another concept which is similar to pagination that is called infinite scrolling. Anyone knows about it?
What is that? Infinite scrolling.
Yes, infinite scrolling. It's a UI concept basically.
Yeah, I'm just thinking that let's suppose
Instagram
it will
newsfeed.
display initially, and then if you'll
Yes.
just scroll right below, then it will
Correct.
keep loading that.
Yes, right. So
Instagram newsfeed.
there are, yes, absolutely. Instagram, Twitter, YouTube, any application you see, most of them uses the scrolling concept rather than paging concept. So only the UI is different there. As you scroll through, as your scroll bar is lowered, they start loading next pages, next few records, right? So it's the same concept, except clickable page link. You have the scrolling, and when you scroll, they load while you are scrolling, right? So they don't load the entire thousands of posts or thousands of tweets at the same time. They do it as you scroll. So that's another concept. Same advantage is that you save performance by doing that. Okay. Now, how can we implement this? So I'll share you the command, how to implement this. In SQL, they have this command, which is select. Then you have the columns we can choose, or we can choose a star. We may have some employee table. Okay. And then we have a keyword here, limit. So you may put a limit, say 5 employees. So let's give an example. Let me share you an example, and we'll implement quickly the pagination through SQL. I'll creating a simple employee table. Yes, so let me create it. So let's say we have an employee table. Let me create here. So we have a table. Let's have primary key, first name, last name, email ID, hire date, department ID. Okay, maybe let's have the salary also. Okay, and let's create this. Yes, so you don't need a comma in the last column. These are the column. We have the primary key. We can yes, insert it by ourselves rather than we can use sequence also here, serial. Yes, this is our structure of the table. So I'm running this query. So relation already exists. Is it okay? Let's see what is there in. Okay.
I think employee table already exists. So
employee table is already there. Yeah. Let
Yeah.
me see what is the structure. They have given this. Yes, let's see what is there. I'll run this. Yeah, they have, oh, we created it last time. Oh, it remembers. Okay. This is what we created last time. So let me reset this data because we'll have a realistic, more better table. So I reset the data. Now, if I run, does not exist. Good. This is what I wanted. I wanted to create the employee table. I'll paste my create table command. This is a better table with a lot of fields. So we have hire date. Okay. And let's now insert the records. Maybe say, let's have 10 employees into this table, right? So let me insert this. So we will use some command to insert. I believe you are understanding how I create this table, right? This command is understandable to you. Correct? Create table. No questions in this. I'm moving.
Yes.
I'm removing it. Yes. Yes. Now let's put insert command. So insert command is something like I'm inserting again all the fields. And now I have to give the values. So let me also bring in some values. I have some test data also. So I will take these values. Yes, I got some test data for 10 employees. So here insert into employee. These are the columns and values and exactly the same order as I'm giving the items here. So first is ID, second is first name, second last name, and so on, email, hire date, etc. Let me run this query. I just see whether say semicolons there. You have to always put a semicolon at the end. Some databases require it, some do not require it. But yes, that's minor difference. Now see 10 rows inserted. Okay, great. So this is also clear, this command. I'll remove this. This is some junk data. I got it. And then let's write a query now. So let's have some query where we will be selecting, let's say we have a page size of 5. Now we have 10.
So you have, okay, you have inserted 10 records. Okay.
Yes, I inserted 10. So we will say select select all the rows, all the columns from employee. Okay. Now I have to retrieve 10, retrieve 5 at a time. So I'll say limit 5. Yes.
Yes.
So now I'll run. So I got the first 5 employees.
Yes.
Right. So this is how I will limit it. How about
so basically, like generally, if you look at that, in a Spring Boot, so we have something like like pagination and sorting repository basically. So basically, like from there, we actually used to do pagination from there as well. So it also fetch only those number of records, right, from DB, like whatever is required.
yes, right.
So we can achieve these things from program as well. And even though we can directly write legacy query, basically, @ query just by saying, if you talk about in Java, and we can just put this such kind of query basically to limit.
Yes. Now see, always advantage to do it in the database, right? Because then database is not getting overloaded. Correct?
Okay.
So yes, if you have the information in cache, then you may use it in the programming level, but yes, better to do it in database level because your queries because your database is transferring all the information to the application server. Application server will have there will be a lot of traffic between application server and database. This will avoid loading extra data from the database. Right now, how to get the next 5 rows? Remember the names, right? John, Jane, Michael, Emily, Daniel. Now I am retrieving the
Offset,
next,
right? Yeah, yeah.
so I
Offset.
can put an offset here.
Yes.
By default, offset is 0. So otherwise, I can give offset some other number, right? So generally we use offset later, but yes, these are the 2 keywords. So I get the next 5 records.
Yeah.
So this is about the pagination. And yes, I did not order it. What I can do is I can also say that I want the ordering also. So here order by, I can give a column name from, say, let's say first name. Right. And let's say this is ascending or descending order, we can specify, but yes, by default, it will be ascending order. So let's say offset could be 0 or 0. So I will get first 5 employees with alphabetical order. Yes, CEO. B is coming first, D, E, I, J, like this. Correct. Now let me give you one more query just to practice. Tell me the employee who has the second highest salary. How will you get? Right? If so, one use of this is pagination. Other very interesting use case is getting some information. So how would you get? Maybe you can put in chat how to get the second largest salary in the employee table.
First we get we'll sort based on the highest salary, and
Okay.
we will take this limit equal to 1 and offset equal to 1. Then it will give the second highest salary.
Awesome. Great. Perfect. See, I have to sort the employees by salary in the descending order because I want the second highest salary. Right. And when I run, yes, I got the second largest. I can check this also. Let's say 2 and offset equal to 0. Right. And I saw. So the first highest salary was 7,000. Next is 6,800. So I got this, right?
Yeah. So this is also like order by salary. So first we are ordering it, and then we are fetching it just by putting offset.
Yes, absolutely. So you can get any ranking, right? Order. You can get 4th largest salary, 5th largest salary, or I can say, give me all the salaries which are from, say, 4th to 7th, right? So in that case, I'll say offset is 4. Now you have to give salaries from 4 to 7. How would you give? What you will give the limit?
Sorry, what you're saying? 4 to 7.
Get me salaries of employees who are having the 4th largest salary, 5th largest salary, 6th largest salary, 7th largest salary.
So first we'll put the limit as 4.
Yes, limit as 4.
And offset will be, yeah, 3rd, right? Largest 3rd, 4th, 5th. So 3 will
Limit
put.
is 3, offset is 4.
Perfect. Perfect. Great. Yes. So this way you will get the 4 employees, 4th, 5th, 6th, 7th. Yes, absolutely.
Someone is saying opposite. I think someone is saying limit 3, offset 4.
Yeah, correct. No, that's so offset is first 3 items we have to skip. right? So if I don't give offset and I just give 7, so I will help them understand. Yes. See, you got the top 7 salaries now. Yes, but we have to skip first 3. So till Daniel, we have to skip. So that's why I'm giving offset 3 here.
Yes, now we got Daniel. James started. Yeah.
Yes, absolutely. Perfect. Great. So yes, this is how, why I, so limit also we have 4. Yeah, we are skipping. So this is the absolute, this is the right one. Great. So
I have one doubt.
yes, show me,
Yeah.
tell me.
So firstly, when we want the first offset, the time taken to retrieve the first offset and the time taken to retrieve the 5th offset, is that same or it will different?
Yes, right. So database will have, if indexes are there, again, it depends on what is the ordering you are asking for. I can say order by higher date as well. Yes. So yes, getting more record is always expensive. Getting less records are less expensive. Right. So this is how
So
your
basically, I think his question is basically, let's suppose if you are having offset as 1 and offset as 100, but limit is, let's suppose, only 2, for example.
yes,
But
yes.
offset we are changing 0. The first time I'm just putting
Yes.
offset as 1. In next query we are putting the offset as 100. So in that case, his question, I feel like, is there any difference in the time?
Yes,
when we are
definitely.
finding that first using first offset and we are finding using the 100 offset or something.
Yes, no, it's all equivalent because database will know how many records are there. If it has indexed the value, then it will be retrieving the records from anywhere will be equally expensive, right? So it's like you have the data, it is highly optimized storage. And I discussed about the storage also in the first class of database. So retrieving any records, it's like in Excel sheet, right? You can go anywhere, it knows where to get, and it does not matter wherever you are retrieving from. Yes, so offset
Okay.
are fast. You can see the performance, right? So we have 10 data, and we'll try that out. Yeah, this is interesting. But yes, we can try that out. But yes,
Yeah, if it is not
see any
same,
problem with that.
yeah, if it is not same, then pagination makes no sense because
Yes, absolutely.
we are retrieving 100, the 100th
Correct.
offset, then we are
Correct.
loading everything again into the memory.
Yes, absolutely.
Obviously, yeah, obviously. Otherwise, there's no meaning of pagination. So
Right. Yes. So now let me quickly take you through some examples of another thing, which is joins. Yes. So let's talk about joins. So let's assume we have 2 tables. Let's discuss about joins quickly, shall we? This is also another important topic because
Yes.
ordering and all is fine. You learned offset, you have learned. Now, one thing I will discuss is join. So let's say we have a table called department, right? So let me create a department table as well. Because see, we have department details of all the employees. That means we know about the ID of the department, but we don't know the name of the department. So let's create a department table. So I'm giving you the command. Maybe you can also try with me. So let's say just have three information, department table. You have department is the name of the table, ID, name of the department, and location of the department, right? So let me run this to get the query, get the department created, right? Now let's insert some data. Let's say we have 5 departments in the organization for which we are building this database. See, we are building an employee database, right? HR system, correct? So let me get 5 department and I will insert 5 departments. So yes, let's say we have this department. Yeah, these are the departments we'll be inserting and locations are also there, right? All departments are in different locations. I'm running this query. Yes. Now you have got all the department inserted. Let's check what is our department table. Yes, you got this. This is the department table. Now, if I have to do a query, which is tell me the department of employee having the highest salary, right? Or tell me the department of employee having second highest salary, something like that. Yes. So how will you do it? You have to give the department name, not the ID.
We have to join that basically. So I mean, we can join that. So basically, like employee is also having the ID, department ID.
Yes, yes.
So we can join it, department and employee.
Perfect. Yes. See, this is one expensive operation because here you are requiring information from multiple tables. Yes. So this is something which is more expensive. Yes. So let me tell you how to write this query. Assume we just want the, yes, there is another, okay, let me also talk about before that. Let's talk about nested query. Yes. So let's talk about. Okay. So there is something called nested query also. So yes. Let me think about, these are various concepts we'll cover. I'll quickly introduce you. There are 2 ways to do this. One is using nested query, other is using joins, right? So let's do the join first, and then we'll do the nested query, right? So let's say we want to select, I'm just changing it to all caps because this is the convention we are using. We want department name, right? So this column is called name. So I'm putting here department name. But yes, there could be a case that employee also has the column name. How to deal with it? Will
Alias.
Yes, you use alias. Perfect. Right. So you have say name from employee, right? So this is the name of the employee. But yes, and then we say join. Yes. But let's say employee, we give a alias E. Yes. So now E, and for department, we give alias D, right? And here, if it is the department name, I'll say D dot name because this means department name. Yes. And then what I need to do is I need to find the name. So I have to join where the ID of employee dot department ID. correct?
Yes.
Should be same as department.id. This part you got. This is very important because we have to get the same department. So the employee department ID should be same as the ID of the department in department table. So if I run this query, and let me format it. Yes, so this is how you do the join. And we see we get all the departments, right? If I put here e.name also, we'll get the employee names also, right? So column e.name does not exist.
First name,
What
last
did
name,
we called it?
first name, last.
E dot, just a minute, let me try recalling. Okay, sorry, E dot first name. Yeah, here we don't have that. We have E dot first name. Let's also get the E dot last name because yes, you may have two employees with the first same name. Yes, now if I go B, you see, I get first name, last name, and the department name. Yes, so here I can give alias for department. For column also. Okay, let me call this. There's just a label which will get printed here. So when I run here, you see here now the label has changed here, right? So this is how you can modify the. But yes, you can use some condition because in this case we also ask that the salary of the employee should be such that it is the second highest salary, right? So that is the tricky part. So what you mean with this is you have to use some where condition because I don't want all the employees. I want employees whose salary is equal to now. This is a nested query, right? Salary. I'm writing another query because I need to get. Yes. Yes. So this is how I'm getting the salary of second largest employee. So I am saying that, okay, the salary should be equal to the employee of the second largest. So this is a nested query example also, right? So I run this, I get this. Yes. Okay, another way, let's. So this is about nested query within a query. Right. So other way I could have done is there are ways of doing it. So let's talk about getting the second max salary. So there is another way. I can use a max function. Yes. From employee. Like this. Yes. So when I run this, I get the maximum salary. Yes. This is another way. But yes, I can also get the name here. Yeah. So let's say I want the first name and I want the last name of the employee as well. I get this because yes, pay attention to these things because these are important. Okay. What happened? Employee dot first name must appear in the group by clause or is used in aggregate function. Yes. So yeah, I am using here aggregate function. And
Yes. Max is aggregate function.
so max is an aggregate function. So I need to get only yes. So here, no.
Group by can't we say group by something like name?
Yes. So that's why it is saying that you have to do group by. Yes. And then I can say first name and last name. Let's try this. Yes, so you got the group by, but this is for the salary you got is maximum salary of each of the group. So it's giving me all the salaries. That's not what I wanted. So I should remove this and then I will do like this, right? So I don't need to use the group by because then you will get all the salary, right? But yes, I can do this way to get the name of the employee. So I say, let's say all the rows we can get from employee where
Salary equal to this one.
yes, right? So this is the way if you want more details. So equal to this.
Bracket is started. Yeah.
Correct. But again, you have to use the alias. So because this salary, it should give a error in this case, right?
No, I don't think so. I mean, should be fine.
It is fine. But yes, for readability purpose, it's better to give an alias here. And you can use here also another thing.
I think same table we are using twice actually. Once we are using
Yes,
an inner
yes.
and once we are using an outer. So
Correct. Absolutely right. You are using the same table. So don't need to worry about it. But yes, for readability purpose, this could also be done. Yeah, always good practice to make things as clear as possible.
Arun, this is self-join, right?
Yes, this is not self-join. This is a nested query. Yeah, self-join is, I would have used the word join on, right, employee.
Okay.
Correct?
Earlier one is
But yes,
left join.
this was, see, by default, when you do a join, there are different kinds of join. Let me introduce that first.
So by default, if you do join, it will be inner join, I guess, right?
Yes, absolutely. Right. So there are different kinds of join. There is, yeah, let me talk about them first. Inner join, okay. And then there is outer join. Okay. And there is in outer join, different kinds of join. So you have left outer join. Then you have right outer join. And then you have full outer join. Yes. And then most dangerous one is anyone knows what is that? Cross join. Yes. We'll go through this with all examples. We'll, yes, try covering this with examples. Yes. So yeah, you remember this, but yes, let me introduce you all these, right? Better to show this using Venn diagram. So when you have, say, assume this is your employee table. And assume this is your product table. Yes. But yes, sorry, not product table, department table. Yes. You may have some departments which are there, which has some employees. Yes. You may have some departments where there are no employees, right? That is rare, but assume we have that situation. And there are some employees who are on bench. They are not assigned to any department, right? So if you see here, so this on bench people, yes, these are the employees which are on bench. Let's assume we have that situation, right? Let me insert that. We have not inserted such employees, but let me insert some employees. I will insert Let's say we have around 4 employees who are in bench. Yes, so we'll do that, right? But yes, you should understand, then you have here some departments which don't have any employees, right? So if these are, say, new projects, right? Upcoming projects. I would say departments, right? Slash projects here. Yes. And this part in the center is where you have employee, and we have where basically this is the departments where your department ID is also matching in the employee ID. Correct? So this is okay. Great. Now let me insert 4 employees who are on bench in the table. So I'm doing this. I have the insert query. I am adding more employees. They have all the data except the department ID is null. Yes. So let me insert this. We got 4 new employees inserted. Let me also insert few departments which are not there. So let me also insert, or let me first select all the employees. Right, you got this? Yeah, I get all the employees, right? There are 4 employees in the bench also here. We have we have departments 1 to 3, which are assigned to people, right? Many departments don't have any employees. Correct? So you can take this practice problem, find out all the departments where there are no employees, right? This could be a very interesting query which you can write. See, these queries will be asked in low-level design interviews, right? So you should practice queries very thoroughly. This is very important for clearing various low-level design interviews. And in any organization, whether it's tier 1 or tier 2, you will be asked to write SQL queries. It's also very important topic for data science or data engineers. So pay attention to writing queries. Yes. So now you see here, we have here our department and employee IDs. Now let me explain you with this diagram what is inner join, and we'll execute the inner join also, right? So when you say inner join means, how do I fill this? So yeah, let's fill this. Right, so inner join is this area. So this part is the inner join, right? So let's try this. So here I can say from employee I did, and I can say join department, right? I can run this query. But yes, this will give an error. Yes, because I have to also specify on which column I have to join. Yes. So I have to say on employee dot department ID equal to department dot ID, because you have to always specify what is the condition for join. We are doing join on department ID of the department. Now I run. You see here, I get the join, right? So what does it mean? I get the department ID, and the table also contains the join of departments. So it shows the department name and department location also for each of the employees. Yes, so this is join. This is also equivalent to inner join. By default, you said is inner join, but I can also type here inner join if I want to specify that I want to run this as an inner join, right? So it has not printed any information about people who are on bench, right? You see here, because they don't have any department, right? I can run this same result. Yes. So yes, here, this is what I meant, that you will get when you do inner join. Inner join is this one. When I do inner join, you will get this employees with departments. Yes. Now there is a concept of outer join. Outer join you can get here people on bench or people on or departments without employee, right? Upcoming employees or upcoming departments or project. This is basically without employees, right? But yes, how to got which one? See, employee on the left, right? Whichever you write first is on the left. Whatever you write on the right is right. Second, whatever you write on second is right. So I can also give here outer join, right? So when I do outer join, let's see what is the result. Yes, it is getting confused. Which one you want? So let me say, I want all employees on the, I want left outer join, right? So you see here, you also get employees which are on the bench here. Yes. So what you get here is basically left outer join is also including this part. Yes. So you are getting exactly all the employees, basically. Even departments null does not matter. Yes, it is also getting that. Yeah. See here. So for null, definitely all the values are null. Right. So I should have copied it, but yes, now I'll copy. Yes, so this one is the inner join. This is the left outer join. And let me also write about right outer join. Right, so in right outer join, let me remove this. And you will get all information here. Yes. Correct. So let's talk about. So basically, you will not get many employees in
Right outer join.
right outer join, but who will you will not get who are on bench, but you will get all the departments, right? But here you were not getting all the departments. You did not got the departments which are without employees. Yes. So here the only difference I need to do is I need to say right outer join. Yeah, this is the command. So you may write right outer join or right join also you can write. Yes. So here now you got rows where you don't have employees, correct? So you got, yeah, for some of the department like operations, you need to know the location and ID, but they don't have any employee, so it's not printing anything. Yes. So this is about right outer join. Okay. Now, yes, there is another join which is cross join. Anyone has an idea what is cross join? No one
Cartesian
knows
product,
about cross join?
Cartesian product of both the tables.
Yes, absolutely. But yes, it's very risky.
I think
If
we can also talk about full outer join, right?
Yes, full outer join also is there. Aha, awesome, nice. So full outer join is both left and right join. Okay, let's do that full outer join. Yes, full outer join, which is both left and right. So you'll get everything. Aha, yes. So you get all the employees, right? And you get all the departments also. Yes. See here, this full outer join. So full outer join is basically full, everything you are getting. So even this is also printed.
This full outer join is a combination of left outer join and right outer join, right?
Yes, yes, correct. It's a union of both left and right outer join. So today, yes, these are all about joins and
But actually it will display, I mean, the value will not be null from both the table, which is common.
no, it is null. See, null is also displayed.
No, I'm saying that the value will not be null for which is actually common ID. Common ID means
That
I mean,
is
let's-
inner join.
okay.
Yes.
No, so it is inner joining and also combination of left and right, something like that. If you look at that, there's a few things which is not null, right? So the things which is not null in the result, they are common, right, in both.
Yes, yes, absolutely. So yeah, this is outer join, full outer join. Yes. I'm just putting here. Right. This is right join. We also call it outer join. Yes. So this is full and you're saying it will contain this or it will not contain this. And this is left join, left outer join. Yes. And inner join cannot be left or right because this is center. Yes. So from the diagram you are seeing that, yes, it cannot have inner or outer join. Outer join basically means everything. Yes. So if you have understood this concept first, that outer join is everything. This is the full outer join. It will also include things which are common. It will also include people or on bench and new projects, right? Everything it will include. And this is what it happened. This is the output. You got all the columns. So you had around 14 employees. All of them are printed. And we have, yes, now I'm seeing one tricky situation. ID is 1, 2, 3, 1, 2, 3, 5, 6. Okay. Let's say I run this. I have employee ID 1 to 14. Okay, but yes, this what has happened is I say full outer join department on employee dot department ID and D dot ID, right? This is easier version. I can say E. Yeah, this now I have used alias. When I run this, so you see here, okay. Where is my employee ID? It is replacing this department ID, right? So I should specify here E
No,
dot ID.
I think 1 to 3 is only common. That's what it's displaying here.
Yeah, because of the naming, it is.
Yeah, because we are joining based on the ID, department ID and ID.
Yes.
So
yes.
1 to 3 is just common. Then it is displaying rest all the things is null, like 13, 14, whatever. It is.
Yes. Right. So let's say we print this. We print D dot ID. Once only we will print, right? And we print D dot name. We print D dot location. Now this is all we are interested in, right? This is good enough information. Now you see here. What is happening to E dot employee ID? Yeah, see, this is some bug maybe in the database. Softwares are always buggy. Yeah. Here I have specified E dot ID. Why is not able to figure out the right employee IDs? Yeah. Why it's just printing? We saw one bug last class also, but here also there is a bug. Yes, we should fix it. It means it should get fixed in Postgres. Maybe in the latest version they might have fixed, but yes, this is something bad. I should have named now this as different, but yes, I know the solution here. Right, let me put like this. It's a optimization they do, but yes, this is over optimization. Now see, it got fixed. Yes. I figured out what is the problem because I was knowing the internals of the database. So I know, yeah, they are doing a lot of optimization. So what they are doing is they see, yeah, you are requesting the same column ID. They are assuming everything and just copying it here. Yes.
Okay, but
Now
that should actually not
this
happen.
they understood. Oh, now I should not copy it, right? So see, this is a bug. This definitely is a bug.
Yeah, because as EMPID is nothing but just renaming the column name. That's it.
Yes, I'm renaming, but yes, it's doing some optimization, which is unnecessary, over optimization, over engineering. Yes, these guys have done. So I'll raise this issue to Postgres. Postgres is an open source software, and maybe I can try looking into the code also if I get some free time one weekend and try to fix it also.
Arun,
Yes.
how did you identify, like, how did you know if you keep that as EMPID, you will get the correct answer? You told some
Yeah,
optimization. I didn't understand. Could you repeat?
guessing. I was guessing. I felt that this is optimization they might be doing. Right. So I felt that when you are not putting this information, I see that yes, what they are doing is they are printing this exactly the same row. Right. So I felt that, yeah, they are doing optimization, and even I have specified here E.ID. Right. So which is E here, but they are not taking. So I said, okay, let me try making it more. I don't know any more things because in SQL, there are not too many things, right? So in column, you have as, that's the only thing you can add to make it more clear that, yes, this is something different so that it skips that optimization. So I did that and then, so yes, some understanding of internals, and based on that, I tried this approach, right?
Okay, got it.
Workaround, right? So
Got it.
if I would have been supporting a customer who is facing this issue, I could have given him the workaround. Okay, please take this workaround. In the next release, we'll fix this bug. But yes, this is something, no, based on just my experience, I figured out. There's no science in this.
Then
Right,
what
so
are the
now I
last two
believe,
records here?
pardon?
The last two records are also null, right? I mean, what are that records?
Last,
Last two rows.
yes. These two no rows, they are
No,
departments.
last two rows, which starts with null.
Oh, rows you are talking about. Yes,
Yeah.
these are the two rows. Yeah. So here it is joining the table. So it's joining the employee table and joining the department table. Now,
Ah,
these-
got it. Yeah,
yes,
got
now
it.
you got it. Yeah, perfect. Right. So that's what, no, we are getting everything here because it's a full outer join. I have written here full outer join.
So basically, like it's coming null because of it is doing right join also. It's
Right
combination
join
of right.
as well as left join, right?
Yeah, so left joining is matching. That's why it is not null
Yes.
in that case, but it is null in other case, right side column.
Yes. Right. Now, if I do cross join basically you don't have to specify the condition. It'll give all the combinations, right? So the last thing is, which is not that useful. So I will give this cross join. I'll run it. It will give you thousands of records.
But nobody uses, right? I
Yes,
mean,
no one uses it. Yes, they just gave it for some convenience, right? Yeah.
Is it cross join means let's suppose we have something like 1, 2, 3 number and other number is 4, 5, 6. So what they are saying that 1, 2, 3, 4, then 1, 2, 3, 5, 1, 2, 3,
Yes,
6.
all combinations they are giving.
All the permutations,
Yes,
combinations.
maybe in testing you may use it if you just want to create some heavy operation. You can.
Tarun, I guess this cross join is used in every join internally, and that will filter.
Okay. Yeah, could be. Yes, I'm not sure about it, but you know this is correct information, or you are guessing?
Then how can like it will match, right? Like firstly it will do
Yes.
cross join.
I believe, yeah, it could be probably true, right? So yes, cross join. Let me, yes, also see what is actually the use is. Use is basically generating. I'll confirm and let you know in case cross join is used in other operations, but I'm not sure about it. I just know that yes, these are Cartesian product, and it is used for just generating maybe more combinations, and its use is just to kind of generate maybe test data. Yeah, but I'll confirm that about is it internally used somewhere, right? So what I mean with this is, let me drawing this is also very difficult. Yes, I can show you picture of what it means. Okay, let me draw this, right? So this is your employee. And this is, let's say, product. We are not interested which product is, sorry, this is your department. Yeah, we are, assume we have few employees here, one employee here, one employee here, one employee here. Yeah, 3 employees, let's say. There are few departments also here. So what it's doing is for each employee, it is giving this as one row. It's giving this as another row. It is giving all combinations of employee 1 with all the departments, which is not the case. Employee 1 is only part of this department, say department 1, but still it is giving combination of all the rows. And it is for second employee also doing the same thing. And also it's giving like this. And also for third also it is doing the same thing. giving all this is Cartesian product. So this is cross join. So these are all kinds of joins which we should know for doing any queries, because joins are very important. They are also very important in data analysis.
Tarun, one doubt. In case of
Yes.
joins and pagination, let's say in one table we have 1 million rows, and another table we have 1 million rows, and
Yes.
we are doing joins. How the pagination is like useful here when we are joining, because lot of rows, how can we load into the memory?
Yes, yes. So I'm selecting, and then you have a cross join, and you can say limit 10. I think, let's see if it works. Yeah, it works.
Yeah, but
Catching it. Offset.
but it firstly joins, then it will select the top, right?
Yes, yes, yes. Right. So you
Then
can.
it has to load all the records, like all the table 1 and table 2 in the first memory. Then it needs to perform the join and get that. So table 1 and
Yes.
table 2 are big. So how can they be brought into the memory?
Yes.
I
Repeat
think
the
here
question.
performance
I
will
couldn't
not
got
be.
the question exactly.
Okay. So let's say in table 1 is huge. It has 1 million rows, and table 2 is there, and it is also huge. It has 1 million rows.
Yes.
Now, when we wanted to load first table 1 into the memory, we cannot load. We use pagination. So now, in case of joins, we have to load complete table. Then only we can join.
Yes.
So how is it possible? Did my question clear?
Yes, got it. Got it. Yes.
So basically here question is basically in joining, basically it will first of all fetch everything, and then it will try to match, and then it will do join, and then further it is going to do limit. So I mean not able to see the benefit of limit here, because it is still loading that for the joining, right? That is what I think Arun is asking. Right, Arun?
Yeah. Like table 1, loading table 1 into the memory itself is tough.
Yeah. Correct.
Right. So join operations are very costly. So I am not saying join operations are less expensive. So the solution in this case is you design it such that you don't need a join. Yes. So we should, this is a drawback of the database design. So better is you design the table in such a way that you don't need a join. Yes, we'll cover the normalization. Then you will be clear with this concept. So yes, so it's sometimes recommended not to use join, and if that is the case, better design it such that you have all the information in the one table itself. Right, add the department name and maybe location also in the employee table. So that is the solution for this problem. Because yes, there will be performance impact if you have a lot of lot of records.
Okay. Then in that case, we should have only one table, right? Like we cannot make multiple.
Yes,
if
yes,
there are
we
any
should-
relationships.
One table only. But then the problem is redundancy. A lot of information is redundant.
Yeah. But many companies are depending
Yes.
upon the SQL. They are maintaining multiple tables.
Correct.
And they have millions of records.
Yes.
If they maintain
Yeah,
one table,
employees will not be millions of. In this case, it's fine. But yes, in some other situation, for example, if this would have been the database for LinkedIn, definitely you have millions of employees. Yes. Correct.
yeah. In that case, they will
There are
maintain
millions
multiple
of
tables.
members. Yes. Millions
multiple
of
tables.
correct. So there using multiple table is a problem. Better use a single table with all the columns.
My
It
doubt
will
is
be
it
very efficient.
possible?
Pardon?
Is it possible to maintain one table, all data in one table?
Yes, yes, it's possible. Right?
Okay. And one other doubt related to pagination. API pagination internally uses database pagination, right?
Yes.
Okay.
So yes, correct, definitely. No, there are different ways of achieving paginations. So one is limit and offset, other is using cursor. So we can talk about when we will be doing real system design problem, we'll talk about other approaches of doing paginations.
Sure. Thanks.
Right? But yes, it's always important to consider the performance implications of all the design, because that's the job of an architect. In system design interview, you should have an eye for performance and reliability for all other issues. Right? Here, see one more point here. If you have, say, employee table, you have department table, maybe there is another table which is sales table. So employee table and sales table, they may contain information which is totally non-related. In that case, you cannot join. There's no benefit in joining these two tables.
Isan, can you mute yourself? I think you're.
Yes. Great. So yes, you can join sometimes. You can merge the tables to improve the performance of your queries. That's one optimization technique. Let's talk about index. Now we have a lot of data in the index.
Taran, one doubt I have.
Yes.
Let's call the table as A and let's call the other table B. Can we have a join to find A minus B? I mean, let's say employee and department, employee minus department, the left part, can we find? Can you take that draw? I mean, yeah, fine. So
You want,
let's say that part.
Yeah, this part, no, on bench, all the employees which are on bench. That's easy, no, you know that the department is null in that case. Yes.
Okay, okay.
Right? So yeah, there is union and intersection also, which you can do. So that's another way that, yeah, probably what other approach you can do is you can do a full join and subtract, yeah, intersection with the right join. You will get, no, the intersection will full join and intersection is okay. Yeah, there are different ways to also write the same query, but I will suggest easier is check if null is there. Department ID is null, then you get it. That's the easiest way.
Okay,
Yeah.
thanks.
Hey, sir, in this case, we don't need to join the department table, right? In the employee table, if
Yes,
department ID.
Yes, correct, absolutely. Yes, correct. So now let's move to the next topic, which is index. See, you may get doubt, but do not worry. We will be covering this in real designs and then we'll get it clarified, right? See, otherwise we will get, I understand this is complex topic. You will be having a lot of questions, but yeah, let's park it offline for covering the other topics. Yeah, so maybe put it in the Q&A so that I also, okay, Q&A is not there in the, you can do it in the chat. If you have the questions, I'll look into that chat message, all the questions. But yeah, let me move to the next topic, which is index. Index, I already shared you how to create. So you remember the structure of employee table. This is our employee table now. Yeah. See, we have so many records. Let's say we index employees on salary. So what we can do is we can create an index. and we have to give an index name. So we can say, we can follow some naming convention. So index is on employee table. I will say IDX, which stands for index. Yeah, let me start with IDX, which is the index. And then I can say this is on salary. Yes. So on employee and then salary. This is how I can index the table with salary. Yeah. I run this. Is created successfully. Yeah. Now my queries which are around the salary will be faster. Where I am asking salary in ascending or descending order, it is faster. And I explained to you last time that we are using B trees here. Yes. There are different kinds of indexes also. So let me cover different kinds of indexes. Yes. So one is this index. Yes, salary index. By default, when you don't provide the type of index, it is B tree index. Yeah. Other way, let index it with say first name. Yeah. So this way I can index this with first name, but yeah, I should give a different name here. Otherwise it will give me error saying that index already exists. But yes, this is the name of the index. But same thing I can do, but I can write another way using B3. Right? Like this, I can say. So when I run this index, this also creates index, but I have created another index on first name. Right? But you will say that, okay, no, first name is not always important. We use both, combination of both first name and last name. So this is the sign for concatenation in SQL. So I can use this index also. See, I'm using multiple columns here. But
So
this
we
is
are
the
doing
index of
we
first
are
name.
doing indexing here, right?
We are doing?
Indexing here, is it?
Yes, we are doing index.
Using B tree, and we are doing indexing on both the column, first name and last name. Both.
Yes, right. But this index is concatenation of first name and last name. Yes.
Okay.
So this is how you will do indexing. Right. So when I run this, okay, some error. Let me see. Yeah, got it. I need one more pair of, because one bracket is for the B tree, because I may do like this also. An index on the name and salary, right? So that's why it was giving error. So now the workaround is I do this. And when I run it, yeah, the name already exists. So I could say here name.
That means with error, it was already created.
Yeah, last time I created on first name. Yes. So I have to change the name.
Okay.
No, it was not created with error. When error is there, no, it was not created. In the previous query, which was successful, it got created. It's not that buggy. Yes, there was one occasional bugs are there, because yeah, we are testing this database like anything. We are running almost all kind of commands. Yeah, maybe the people who are developing are not testing that much, but yes, this is, yeah, some quality is there in this, no problem. Yeah, so this is, this was in my previous successful command when I indexed with just first name, the same index existed. Yeah, so it was for this successful execution, we got that created. Yes, so this is about B trees. Now next talk about another kind of index, which is called BRIN index. BRIN index are called partial index. Yeah. So I want to index the salary, but I want to only index employees who have salary more than, say, 6,000. Yes. I can even do that. Yes. So to do that, I have to change the syntax. I have to say, instead of here, on employee, where, and then definitely I have to put here salary, where salary is greater than 6,000. Yes, so this is a partial index. So you don't have to index everything in the table. You can do partial index. This is also called BRIN index. So I need to put here the name, different name now. So let me put some name like that. This is a BRIN index on salary, right? I can use some more descriptive name like 6,000, right? So yeah, let me run this. Yeah, got created successfully. So these are the two types of indexes, B tree index and BRIN index. There is another thing which is hash index. And there is also something called GIST index. So there are different kinds of index. Let me tell you the list of indexes and I'll describe them. You can try it out.
What are the difference also, like maybe?
Yes, I'll tell you. Yeah. So first is B tree index. Yeah. This is the data structure. Yeah. And this is the most common one. Most of the time, it is the default index technology. So, but yes, knowing the indexes, different kinds of indexes, and when to use which kind of index is very important. B trees are good for range queries, right? Say if I want to find employees having salary between, say, 5,000 and 7,000, right? Such queries are good for B trees. These are range queries. Example of D. B trees can do that. Hash map cannot give you this kind of query fast. If you create a hash table, it can only give you one value, right? But there are, in case you need for such optimization, then you use hash index. Yes. So there is possibility of hash index also. So let's say for last name, we need a hash index, right? So I'll say last name here. And then you have here last name. And then, yeah, you don't need this condition. Condition is for partial index, but yes, this is. So because last name, I will always be interested in searching all employees with a particular last name. So I'm using this last name as hash index, right? So create index. I should also tell this that, okay, this is hash index. So I have to say employee using hash index on last name. This is the syntax.
His last name, Alias.
Yeah. Right. So typo. Yes. Now it is created hash me. But yes, you don't query like give me all employees whose last name start with, say, C to F. Yeah. That queries it will not be able to optimize. It will only be able to optimize search queries, which are where last name equal to Sharma and last name equal to some XYZ Reddy or something. Yeah, like that if it is there. It will be able to optimize, but it will not be able to optimize range queries. And partial index, we also saw partial index will be able to optimize that particular range of the values. You use partial index to optimize. Yeah, you don't need sometimes all the data to be indexed. So they are there. You have this option for flexibility, additional flexibility, and performance improvement. So this is for exact searches. Yes. And then, yeah, in databases now, a lot of features are there. So you are having a lot of different kinds of indexes. There is something called GIST index. This is called generalized search tree. Yeah, this is the name of the data structure. And this is basically used for geometric shapes. Now, storing geometric shapes and queries involving nearness. Right, so it's generally used in geometric queries and also sometimes text searches. Right, so documents, on documents it's used. So this is another query, another kind of index. There is another kind of index which is GIN index. Yes, this is called generalized inverted index. Yes. And then last, there is one type which we already saw, which is BRIN index. This is block range index. Yes. Correct. So this is basically partial index. So these are different kinds of index. Now, generalized inverted index, this we will cover because this is also used in some databases, NoSQL databases like Elasticsearch. So we'll be covering Elasticsearch also. And it will be in using Elasticsearch, we'll be writing some search engine. Maybe we'll do some application which has some search requirements. In that, we will cover inverted index data structure. Is a very important structure. You can read about it also in advance. But yes, it's a simple data structure. This is created with inverted index, with GIN index, which is generalized inverted index. So now you are clear different kinds of index and when to use which kind of index. Right, see, all this information is based on my experience and a lot of research. So understand and remember it thoroughly. And these are very important because you can talk about all these in the system design interview whenever you are designing a database and whenever you are optimizing your queries.
Tarun, can you tell the B tree once again with an example?
B3, I showed you using a simulator, right?
Yeah, can you explain that once again, please?
Yes, we'll do that. I will give you the URL so that you can also try it out because and just in a minute it will become. There are data structures called B trees. There's something called B plus trees also. You should know all these data structures. So I'm again into this data structure. So assume we have to insert some salary information. 5,000, I insert. Then there is another employee who has salary, say 4,900. I insert. See, it's like a binary tree, but it is different than binary tree. because it is used for range query. Binary tree again is used. Binary search trees are used for searches. Assume you have some other salary, insert. Yeah, it's bigger, so it will come in the right. So right now it's like binary tree. But yes, now I'm inserting more element. Every node is containing 2 elements here. That's why it's called B tree. Binary tree is given already. Yes, used by some other data structure. So they called it B tree. Let's say here you have, right, some other value. Right. And then if you are inserting, say, some other value, and yes, see here, the root can also contain 2 nodes, and splitting also. See, it's complex data structure, not that easy. You have to split the node, you have to add the value in the appropriate position, right? And then I will say, I want some other value 6,300. So it will insert here. Right? So that's why I'm simulating, I'm not drawing, because it is little complex. See, now it has modified. Let me add one more value, say 3,300. It will always be balanced. So that's another advantage. See, it is always balanced. It's not that it will be like leaning towards left or right. So it's a very interesting data structure. Read about it. This you can cover in data structures. Yeah, code also, you can code for this. Correct. So it can be used for doing range queries. So let me insert one more value, because sometimes, yeah, when you add more values, you will be clear with this. Yes. So let me add, because I wanted to demonstrate you one concept. Yes, now I should be able to demonstrate you. Yes. See, yes. Now the concept is, say, assume you gave a range, which is like 4,000 to 4,700. Yes, you can get this data very easily because this is available on this part of the tree. Yes. So it can do range query very fast. Yes. So how to do range query? You can also try it out using code by yourself. Clear? B trees. I will give you this URL. Yes. So that you can try out.
Yeah, the range has to be only 3. The range has to be the difference between the lower and maximum has to be different 3, or it can be anything. Range query.
Pardon, I'm unable to hear it properly. Your voice was having some echo. Can you repeat?
Okay. So this is used for range query, right?
Yeah, this is used for range queries. It can do exact queries also, but yeah, it can do range queries as well.
Yeah. So in the range query, we took maximum degree equals to 3, right? Here, building is B3, we took maximum degree is equal to 3. So the range difference has to be 3, or it can be anything in that query.
Yeah, range query, yes, definitely. So you have difference should be, yes, it should be range. Yeah, bigger ranges, many values should come within that range. Yes, because you may have also duplicate elements also. So not all the elements have to be unique. You may have duplicates also. Yes. See, you have the duplicates here also. 4,500, 4,500. So this is about the B trees. Yes. And There is another query which is important. Over a period of time, all the index will become corrupted. They will not be effective because you may have a lot of insertions, lot of deletions, lot of modifications of data in the table. Assume salary everyone is getting promoted and everyone is getting hikes and bonuses and their salary revisions and all. Over a period of time, this index will become obsolete. So you have to use this command, reindex command. So don't need other details, just say reindex command. It will reindex your reindex index. And then you run it. So it will reindex this command. It is index, whatever name you have provided. It takes some time because this, if you have a lot of records, it'll take a time, but when to reindex, if you see your query performance is getting worse, so you can reindex or you can do it regularly in your tables. This is a database maintenance activity. Yes. There is another command which is drop index. Right, drop index. If you have too many indexes, then that's a problem also with respect to performance. You may sometimes want to drop the index also. So this is the command for dropping index. This will delete the index. Okay? The index is gone. I don't know whether this will work or not, but this does not support this. This we tried last time. This we have only some limited access. Not all commands will work here. But yes, all these are important commands for building any applications. Okay. I'll cover one more concept, which is a very important concept, which is the last concept of database topic. Mask replication and all other things we'll cover as we will go further. But yes, let me cover. This is also the most important concept. Although it's the last topic, but it's a most important topic. This is about transactions. So for transaction, for studying transaction, let's get into again execution mode, because best things are understood when you are doing hands-on. Let's create a table which is account table, which is account number, customer name, and then you have a balance which is in numbers. It's some amount. Let me run it. Table is created. Yes.
Money is the data type here.
Money is the data type available in Postgres. Correct? Yes. Now, wow, you got a salary, assume. So when you get a salary, bank employees will run this query, right? Assume 100 rupees what you got. Someone transferred to your account some money. Yes, it's okay. This is say assume interest, because I'm updating account and I'm not putting any where condition. Basically, I could put a where condition also, but yes, before let me create your account. So let's say I am creating an account. Yes. Name of the person is this guy. This is the account number. It's a string, so I could create this number. This is the initial deposit, 1,000 rupees. I create this account. Okay, insert into, yeah, this part I can remove. So this is a simple create table command. We know this. Yes, now we do insertion. I run here. Yeah, this insert is already there. Let's print the passbook for the person. Right, so maybe passbook or report. So let's do, I have only one customer, so my bank is, yeah, writing queries is easy for me. Yes, so I got this information available. So you see money database data type is there, so you got the dollar sign here automatically, and then there is a comma sign also. Yes. So until now, this is just the data structure or database schema for which we will be performing some transactions. But yes, if you have to perform any transaction, basically you have to do 2 accounts. But yes, in our case, assume we are getting some transactions and okay, let's insert some other employee also. Yes. So that we can show you the transaction concepts. So let me insert another employee here. So let's say this is the name of the employee. He has a different account number because that's primary key, so it has to be unique. And let's say the balance is 500. So I run this, it is inserted, and I can select the 2 employees, two account holders are there. I got 2 customers now in my bank. Now assume Jane transferred to Timothy 100 rupees. Yes. So to begin a transaction, you can use the begin statement. Yes. This will create or start the transaction. Then you can say insert into account. Sorry, not insert, you have to update. Yes, so I have to give update command. So 100 rupee transfer is happening, right? Who did the transfer? So see, set balance equal to balance plus. This is for typecasting. Yeah. I can put where account number, because I will say account number is this. This is the receiver of the money. Yes. So you have to update this. And the other person is the depositor. So here I have to minus it. Right. So let me format this. Yes. So this is clear for you guys. You are beginning the transaction. I'm running query number 1 and query number 2. Yes, all together. And then finally, if both are successful, I will commit. So commit. Commit is another transaction.
And end.
Yes. So when you execute it, yeah, now it will run as a both will happen together, or one of it will happen. Yes.
Where has to be the last, right?
Yes, yes. That's what I'm updating. Yes. So
And we have to put and, right? Like how we are putting begin.
And no, end is
After,
commit.
after
Commit.
commit. Okay, okay.
No end, it's commit. Right. So same I need to do for other also. So this is how you will run the query. Yeah, so let's see here. I'll run. Okay, comma, semicolon. Yes, query is done, right? So let's see if the money got transferred or not. Yes, so when I run, money got transferred, money got detected also properly. Yes.
Yes.
So that transfer happened from Jane to. So this is about.
Yeah, previous balance was 500 for
Yes.
Jane. It was
Correct.
1000 for him.
Correct, correct. So assume this is SBI. Yes. And again, there is one more transfer done. So we'll demonstrate the rollback. Yes. So again, I'll start the transaction. This is another transaction. That transaction has ended because after commit, the transaction ends. Yes. So let me put again the, sorry, begin is already there. So let me put here the update to account. Yeah. So here where, say this is one more, sorry, I can do this. Can put anything in where, no problem, but yes, account number equal to, yes. So here, so let's say the other way around is happening, but here we got lunchtime, right? So now I should deduct this money, but yeah, somehow some problem happened, or yeah, or the time up for doing the transactions and all, bank closed, right? So what we can do is roll back. Yes, so I am updating this and then doing rollback. Let's see. Yeah, done. Let me see what has happened. Yeah, see, same state is there. Transaction got rolled back. So these are the commit and rollback command. This is the transaction management, which you get free of cost in PostgreSQL. Yes. See, till where the rollback will happen. Where until from where you started the begin. Yes. Or the previous save point. Let's say I am adding the interest, right? Here to everyone. Let's say 10 rupees the interest, or this is some money I'm giving everyone, or yeah, let me deduct, assume, yeah, this is the maintenance charges I am deducting. Now I am beginning the transaction. And later assume there is an update. Single quote is required for strings, right? So now I will roll back. Yes. What do you think? 10 rupees deducted back or will be charged if I do a select query?
It will be deducted. Because
Right?
we have
Because I'm rolling back,
declared-
but rolling back is happening till begin. Yes.
we have actually begun the transaction. Yeah,
Yes. The transaction will roll back until begin. Correct. So when I run this, let's see. 2 rows updated and
it should change, right?
huh?
The
Yeah,
value should.
We should execute one by one, I guess.
yeah. Probably it did not got executed. So let's say, let me try again. So yeah, let me yeah, you're right, because depends on the setting also of the database, but yes. When I execute this, 2 rows updated and see, there is a concept of auto commit. Yes, anytime you do any update, probably commit is something which is important.
Yeah. Commit and then you can again further another statement and then commit.
Correct. So, because again, depends, there are different kinds of settings in the database. Right. So, which is, I will just share you, but yes, let's try. When I commit now, see 2 times it got committed. Yeah, which happens in SBI a lot of time. Yeah, maybe. So the previous one also got committed. Yes, so there is no auto commit, but yeah, when I did commit, that was uncommitted. So it was not showing you in the search query. Right? But yes, this is a good demonstration actually. Not intended, but we got good demonstration of this concept of commit. Yeah.
How it got 20 rupees deducted? It should deduct 10 rupees, right?
10 rupees got, but yeah, there was one transaction which was pending.
Maybe not
Previous
closed.
step. That also got. When I did committed, there was, see, we did 3 transactions. What I
Yeah.
said earlier was I ran this command. Yes. So this is -10. Yes. Then I started that transaction. Right. So we gave this command. Right. This command we gave. Yes. But what I did was I did rollback. Right. So when I did this, I'm doing again. You can see now and understand it. I'm doing
But it did 20 rupees minus for both accounts.
yeah, yes, because this is for both accounts. I'm not providing a where condition here. So it's doing to all the rows. Yes. See, I'm demonstrating it again. Now again 20 rupees will get deducted. See, yes, the bank is getting richer and richer. Yes, so here, since rollback has happened, so this transaction is also not committed. Somehow, but yes, let's run this again. So it's there, yeah, and because yes, rollback is generally an error situation So it is not executing even the select statement also. This is a session. So now I will see this select. Now nothing is deducted, right? Same 20 was, this was the balance originally. But what I did was I updated again.
Just to do commit instead
Just
of
do
updating.
commit, then 10 rupees will get deducted. Yes.
Okay. It should deduct only from the first one, not just from the second one.
No, second, both were there. Both were there.
We added the where class, right? Where and account
Oh,
number
we added
equals.
this.
Yeah,
Okay.
yeah.
I do not remember that, but yes, if we have added, then it will be from one account only. Right? Let's see this. Yes. This is now it is not doing anything. Yes, because yeah, it did not do. I need to get that probably with the next update only it will do. Yeah, sometimes that's why your balance is sometimes not reflected. Yeah. So now I do this transaction and is updated now. And let me do here select. Let me do even before that commit. Yes, so let's see what is happening. Yes, commit is happened, end of transaction. Now I'm printing this. Yes, see, now got deducted.
10 rupees from both,
Yes, yes.
not 20
Yeah,
rupees.
that got rolled back. The other one got rolled back. Maybe that time what would have happened when I was clicking on run, it got executed twice. Maybe.
Maybe.
Yeah, could be there. But yes, it is then behaving perfectly. Yeah, it's behaving perfectly. But yes, this is all about rollback and commit. This is how you ensure that transactions there, either both of them got executed together or one get both of them got rollback.
One last time, update this with -10 and do that commit. Let's see. If we are adding update commit, it might be executing 2 times.
Why it will execute 2 times? No, it should not.
Okay.
But yes, I will. Let's try it out quickly. Okay, I'm trying to copy paste this. Or yeah, I have this already. So I did this, and then I say commit. And then I do the select. Yeah, looks like, yeah, correct. Yeah, it's no, only 10 got deducted.
Got deducted. But I mean, like when we executed 2 statements, update on top of this, do that update.
Yeah, now this is there. When I do this, and now I remove it. Yes. You can play around with various scenarios here. Yes.
10 to 10 only.
So probably I would have clicked here twice while I'm updating it. So yes, that is something. But yes, I'm sharing to everyone the link. You can try out, commit and begin. And there is also something called Savepoint. Right. So you can also define some Savepoint. I will give you an example very quickly. Okay, so yes, like this you can create some save point. Save point is used to roll back to that particular point. Assume you have some insertions also here. Okay, insertions, and then you have save point, and then maybe you have some updates, right? So let's say we have some updates, and if something fails here, assume there was some transaction, we are running a lot of things together. But yes, what we can do is we can do, say, save point to this.
Then we can roll back partial transaction, right?
Yes. Now go ahead. Yeah, this is how you will do save point. So it will only roll back to the previous save point. Yeah, so probably this you could try. Yes. Yes, someone was asking some questions.
Using save point, we can partially roll back the transaction, right?
Yeah, yes, absolutely.
Okay. And I have another doubt. While creating table and inserting data, we don't use commit, but here we are using commit. How did it work there?
Yeah, there is a concept of auto commit. So you can explicitly begin a transaction. But yes, when you begin, then you have to close it either by rollback or commit.
But for update, we didn't start with begin, right? But we tried with commit.
Yes, because if you do not begin, so there is no transaction, but yeah, it will get committed. Yes, it will
That
get
means
committed automatically.
when you're doing begin
Next.
word, then you have to commit manually, basically, either
Yeah.
by rollback or either by commit. But the statement, if you're writing directly, so here it is auto commit.
Yes. Again, there are various configurations available. Auto commit could be turned off also. So there are other configurations, database configuration, but yes, there could be situation that auto commit is enabled, right? So this is about transactions. And yes, maybe next time, maybe I will need 10-15 minutes for database concepts. We'll go to the low-level design. We'll discuss about various low-level design concepts in the next class, which is solid principles, principle KISS, and principle of various other how to write clean code. Yes, we'll cover next time. So object-oriented concepts, clean code, and all various best practices which you should follow in low-level design. You should also follow these in any other design or data structure interviews. So next time we'll do a problem which is let's do building some game which could be a Ludo game, right? Online Ludo game. The same architecture you can use for any other online game. So we'll do the low level design of a chess game, or could be any other game like Ludo or snake and ladder game, online game with multiplayer. So that will be the topic of next class, how to do low level design of these applications. And we will also cover about locks and deadlocks in database. So that would be last topic of database. And then definitely low level design. And then we will proceed with the design patterns and then come back to various other architecture concepts related to high level design. Yes, so after covering low level designs, we can cover various some NoSQL databases also, but yes, we will do some practice of high level design problems also. So this week we will see low level design and high level design. Great.
Tarun, deadlock in operating systems or DBMS?
Yeah, we will cover in the database. When there are locks, you may have two queries waiting for acquiring the lock, and then you can have deadlock. Right, so we'll cover that. How you can ensure you should know about this concept also. The same concept also applies to database. It also applies to operating system. Correct? Sure. So let's close this session, and next time I'll cover the queries, questions on this. And until then, you can try out. And I will also review the assignments which you have shared. Those who have shared, this is nice. I will share the review comments to you back via email. We may discuss it also if there is something considerable input if I want to give in the next class. But those who have not submitted yet, they can also try it out. It's simple. Assignment should not take you 15-20 minutes more than that. It will give you a lot of practice. And you may also try, I will also upload one more assignment, which will be using transactions. Right? Or I'll upload one more assignment, which may also use some other concepts which we covered today. It would be online retail store. Hide it.
Yeah.
Switch it, say that, okay, yeah, this is a startup and there was also some economic problem, business problem. So you decided to leave again because yes, you were looking for long-term opportunities. So this will, when you say like that, no, they will understand that, yes, you are not someone who is looking to switch. You are switching because there were economic problems and external factors, which has happened in both these cases.